Hello, algebra students. So this next video is about simplifying radical expressions, and mostly when we have a quotient dividing. So this first example, when we want to simplify an expression, remember that you're trying to do a few things. First, you cannot have any perfect squares under the square root. This is what we did last section. You cannot have a radicand that contains a fraction, and you cannot have any radicals that appear in the denominator. So the first rule that you can do is just like the quotient, or just like the product, you can take a quotient and separate square root of 10 over square root of 2. And if it is separated, you can put it together. Square root of 5 over 3. So if it is already a quotient, you can separate it into two square roots. If it is two square roots, you can put it under the same radical. But when you look at these, you do have fractions under the radicand, and you also have a square root in the denominator, which you cannot have. So let's see if we want to simplify some fractions. So first, this one is a full fraction underneath the square root sign, so I can separate it into square root of 4 over square root of 9. And we know the square root of 4 is a perfect square, so that's 2. And since 9 is a perfect square, the square root is 3. This next one, same idea, we're going to separate. So we have the square root of 10 over the square root of 9. Again, in the denominator is a perfect square, so you have 3. In the numerator, I have a square root of 10. That's not a perfect square. Can it be broken down or simplified? It's 5 and 3. Nope, there are no pairs, so it stays the square root of 10 over 3. And again, the bottom does not have a square root in it anymore, so no radicals in the denominator. Got that? The radicand cannot contain fractions, so underneath the square root here is not a fraction. The entire thing is a fraction, but under the square root is not a fraction. And then the top square root is as simplified as it can be. So again, we're going to simplify by separating square root of 96, square root of 100. The bottom is 10, square root of 100 is 10. But the top can be simplified. So we're going to take this 96, square root of 96, and we are going to break it into its prime factors. So we have 3 and 32, 2 and 16, 2 and 8. 8 is 2 and 4, and 2 and 2. So I have a pair of 2's right here, pair of 2's right here, and then this 2 and this 3. So 2 times 2 comes out, so you have 4. And the 2 and the 3 stays under, so that's 6. However, you also must make sure that you simplify as carefully as possible. So here I have 4 and I have 10. Both of those are outside of the square root. So just like when we are multiplying things that are outside the square root, we can simplify things that are outside the square root. So I have 4 and a 10 simplifies to 2/5. So it's 2 square root 6 over 5. Next part, again, we are separating since there is a square root and there's a fraction, which you can't have. The bottom is a perfect square, so it comes out as 4, and the top does not simplify. So now we have variables, but nothing really changes. You separate them, 25n squared, and that is a perfect square. 25 is a perfect square, and n squared is a perfect square. So 25 comes out as 5, n squared comes out as n, and the bottom square root of 4 is comes out as 2. And last time, you guys try this one. Separate it. The bottom is a perfect square. 4 is a perfect square. T to the 4th is a perfect square. However, the top does simplify. So square root of 32, I'm going to break that down. 2, 2, 2, 2 and 2. Pair of 2's comes out, another pair of 2's comes out, so that's 4, and then the square root of 2. However, again, I have this 4 and this 2 out front. They're outside of the radical, so we can simplify those. So it becomes 2, square root of 2, over 1 t squared. We don't really write the 1. All right, so in all these cases, we had a denominator that was a perfect square, so we fit this third rule, which is no radicals in the denominator. But what if your denominator is not a perfect square? For example, this one. When we try to simplify this fraction, and we separate into 2 radicals, I can't simplify the bottom here. What is different is that the denominator is not a perfect square. So we must do something called rationalizing the denominator. If the denominator is not a perfect square, we have to do something called rationalizing the denominator. And we're going to do that by multiplying the numerator and denominator by a factor that will eliminate, but that factor has to be 1, which sounds a little weird, but here we go. So same idea, we're going to take that and we're going to separate it. Square root of 5 over square root of 3. So this is not a perfect square, but I cannot have a radical in the denominator. So the only thing you can do to an item to not change it is multiply it by 1. So I need to multiply this by 1 to keep its integrity, right? The left is x, the right is x. So multiplying something by 1 won't change its value. So I need to keep the value but change its look. So I need to multiply by 1. What version of 1 will get rid of this denominator? The version is the denominator over itself. Well, how will that work? If I multiply by the denominator over itself, and radical 3 over radical 3 is 1, the top, I have 2 radicals and their product, so the top becomes square root of 5 times square root of 3, and the bottom becomes square root of 3 times square root of 3. And now I have a perfect square down here. So now that I have a perfect square down there, this becomes the square root of 15 over 3. Again, check that the square root of 15 doesn't simplify. It's 5 and 3, and there's no pairs there. So this is your final answer. We'll try that again. So we have a square root of 12 over the square root of 10. However, when I wrote this, I forgot to check first if I can simplify under the square root. So 12 and 10 do simplify. And the reason I'm doing this is because the denominator is not a perfect square, I can simplify this. And if I simplify it to the square root of 6 over 5, and then I separate it, my problem is going to end up with the same answer as if I left it, and I'll show you that in just a second. But simplifying it is the faster way to do this. So again, I have a radical in the denominator, which I can't have, so I'm going to multiply by a version of 1. And the version of 1 I'm going to multiply by is the denominator over itself. So multiplying by this version of 1, then my top is going to be 6 times 5, that's 30. And my bottom is 5 times 5, so that's the square root of 25. And the denominator now is a perfect square. And 30 is 5 times 6, which is 3 times 2. And no, there's nothing that comes out. None of these have pairs, so it stays the square root of 30. What if I didn't notice it could be simplified? Well, at this point, when I took it apart, I would multiply by the version of 1, which is the square root of 10 over the square root of 10. And I would end up with the square root of 120 over the square root of 100. But this does simplify. Sorry, square root of 100. This does simplify. The bottom simplifies to 10, and the top actually simplifies to 5 radical 30. Oh, 2 radical 30. I can do that on the side over here. 120 is 12 and 10. It's 5 and 2. It's 2 and 6. It's 3 and 2. Pair of 2's comes out as a 2. 5, 3, 2 is the 30. But I'm not done here because the 2 and the 10 simplify. So this 2 and this 10 simplify. 2 goes into here once, 2 goes into here 5 times. So the top is now a 1 and the bottom is now a 5, and I have the same answer. So by simplifying first in the first place, you avoid having to simplify at the end. So let's try that out over here. I have 35 divided by 15. 35 divided by 15 does simplify. A 5 goes into the top, and a 5 goes into the bottom. So when I divide out that 5 from the numerator and the denominator, now I can separate them. So that becomes 2 times the square root of 7 over the square root of 3. The 2 is still in the numerator technically. You can put it out front or you can put it in the numerator, but I'm going to go ahead and simplify this first, multiplying by the denominator over itself. That's the version of 1. You can only multiply by 1. You end up with, the 2 is still out in front, and then you have 7 times 3, which is 21. 3 times 3, which is 9. The bottom simplifies, so we end up with 2 square root of 21 over 3. The 2 and the 3 don't simplify. The 2 and the 3 that are outside do not simplify, so that is your final answer. All right, we can do one more example together, and then you'll try a few of these. I have the 4 out front. Don't ever forget about the number that's out front. Sometimes you do. It's a very common mistake. And then I'm going to look, can I simplify anything under the radical? I cannot, so I'm going to separate it. 3n over square root of 8. I'm going to multiply by a version of 1, which is the denominator over itself. There's also a common idea that maybe you simplify the denominator first. That's okay. If you do, then you won't have to simplify at the end. But let's try this out. So I have 4 on the top. Square root of 3n and 8 is the square root of 24n. On the bottom, I have 8 times 8. That's the square root of 64. So the bottom becomes 8. The top, I have that 24 there. How does 24 break down? Into 4 and 6, 2 and 2, 2 and 3. So I have a pair of 2's comes out, and then the 2 and the 3 stay under. So I already had a 4 out here. The pair of 2's comes out as a single 2. And then the 2 times 3 and the n stay underneath. That's 6n. Now what happens here is I have 8, 4 times 2 is 8, divided by 8. So my final answer is just the square root of 6n. Because this 8 on top divided with this 8 on bottom. And so I was just left with the 6n. All right, now that I have them separated, again, you can put them together if you want to. Or you can go ahead and multiply by the denominator over itself. I'm going to put them together to show you that method. So this can become square root of 6y over 12. The 6 and the 12 divide. That's 1, and 6 goes into here once, 6 goes into here twice. And now when I separate them, and I multiply by the denominator over itself, to rationalize the denominator, my final answer comes out to be the square root of 2y on the top. The bottom is the square root of 4. But this 4 is a perfect square, so I end up with 2y over 2. All right, you guys go ahead and try this last problem here. All right, again, you could have simplified this 27 and brought it out, but instead I'm just going to go ahead and multiply by this version of 1, which is the denominator over itself. So the top will become the square root of 135 m squared, m to the 5th, and the bottom will become square root of 5 times square root of 5 is square root of 25. So up top here, I did the simplification of 135. I have a pair of 3's, so the 3 comes out. The 5 times 3, the 15, stays under. But I also have some m's here. So this is 2 pairs of m's, so m to the 4th comes out as m squared, and you had an extra m left underneath. And then on the bottom, this becomes 5. Now you cannot simplify under the square root and out of the square root. You can only simplify things that are out of the square root together, or you can simplify things that were under the square root together. So if they're both under, they can be simplified. If they're both out, they can be simplified. But you cannot simplify something under the square root with something that is not. So this is your final answer. All right, put it on pause. I'd like you to try these 3 problems. When you have square roots, there are different ways you can go about it. So again, you could have simplified the 8 first and then multiplied, or you could have taken one of the pairs of g's out. But again, in the end, we should end up with the same answer. So in my case, I just multiplied by the square root of 8 over square root of 8. Well, this is my version of 1. I got square root of 8g to the 3rd over square root of 64. The top, this 8 simplifies, and so I have a pair of 2's comes out. I have g to the 3rd, so I have g times g times g, so I have a pair of g's, and a g stays under. So I have what? 2 that stayed under, and a g that stayed under. And in the bottom, I have 64, which comes out as 8. But again, things under cannot be simplified, but if they're both out, they can. So this 2 and this 8 simplified, so I'm left with g square root 2g over 4. So the first thing we did was look to see if there's anything we can simplify because it was a fraction. I can simplify these x's, x to the 5th and x to the 2nd. Those cancel out and you're left with x to the 3rd in the numerator. The coefficients do not cancel and there's no other y to cancel. So then next step was to separate them and then multiply by the denominator over itself. And then finally, once you multiply the tops, multiply the bottoms, you can simplify. 30 does not simplify. X to the 3rd does. You have a pair of x's in there, come out as a single. So the 30, the extra x, and the y are all left under. And in the bottom, it's 2. Again, you cannot simplify the 30 and the 2. 30 is under the radical, 2 is outside the radical. You can only simplify outside with outside. Try this last problem. So one of the issues is you could possibly, first of all, you can't simplify underneath the square root. Nothing under here simplifies. But when I separated it, I could possibly simplify this x squared and bring it out as an x, but I just left everything under to not confuse what's out and what's under. So then I just multiplied by the denominator over itself, and then multiply the tops, multiply the bottoms, and actually you can skip that step. If you know that you're multiplying together the square root of 2 times the square root of 2 to get the square root of 4, and it's just going to come out as 2, you can skip that middle step right there. Right? If you know you have the square root of 8 times the square root of 8 is 64, and the answer is 8, you can skip this middle step right here. So instead of multiplying these together and then bringing it out, I'm going to bring it out all at the same time. So the denominator is just 7x squared. Multiplying something to itself under the radical will come out as itself. And then the top multiplies together to give you 280 x squared. And when you simplify the 280, you get 2 on the outside. And x squared comes out as an x. Underneath the square root, when you simplify this 280, you would have had a 2, a 5, and a 7. So you can put those all together as 70. And the bottom is still 7x squared. Is there anything you can simplify? Don't say the 70 and the 7. 70 is underneath, 7 is out front. So what we need to do is simplify these x's. But you have an extra x on the bottom and not on the top. So if I cancel them out, this x would cancel with one of these x's, and I'd be left with one x on the bottom. So your final answer would be 2 square root of 70 over 7x. This last section involves fractions underneath radicals being multiplied to itself. So it's everything all in a nutshell. So what we're going to do is start by multiplying them together. So the square root of 1 times 3, square root of 5 times 6. Simplify underneath the square root. Separate. Then multiply by rationalizing the denominator. Multiply by the denominator over itself. The top is the square root of 10. The bottom is the square root of 100, which just comes out as 10. You cannot simplify these. One is under, one is out, so you are done at this point. Next problem, you try the same way. So I wanted to try to simplify. Once I multiplied them together, I want to try to simplify, but they have no common factors to be able to simplify. So if I just separate, I could possibly multiply by radical 80 over radical 80 to rationalize the denominator. But what I'm actually going to do is, because I have these factor trees, I'm going to simplify the denominator. If you do this differently, we still should end up at the same point for an answer, but there's a little bit something that maybe you want to do when the number is this big. So I'm going to simplify. 2 times 2 is 4, radical 5. And on the top, this is 3, radical 3. So now I have this scenario right here. I have 3 radical 3 over 4 radical 5. So when I rationalize the denominator, I only need to multiply by what's under the radical. Since it's a monomial, I'm only multiplying by what's under the radical. So I'm going to rationalize here by multiplying not by 4 radical 5, just the radical 5 over radical 5. And we'll see what that does in the next step. So I have on the top, the 3 is on the outside. The radical 3 and the radical 5 become radical 15. On the bottom, the 4 is on the outside. Square root of 5 times square root of 5 is square root of 25. So the denominator becomes 4 times square root of 25 is 5. So your final answer is 3 radical 15 over 20. Well, let's make sure it's the final answer. Can I simplify anything that is out? 3 and 20 do not simplify, so that's it. Go ahead and try this last one. All right, so I multiplied them together. I had 35 over 6. That cannot be simplified, so I separated it and then multiplied by the denominator over itself to rationalize the denominator. So the top becomes the square root of 210. The bottom becomes the square root of 6 times the square root of 6, which is square root of 36, which comes out as a 6. And then the 210, we can go ahead and check it out. I think it's 7 times 3 times 2 times 5. So there are no pairs. So that's your final answer. All right, let's try one with variables. This next one has a 3m and an 8, can't be simplified. 5m to the third over 3 can't be simplified. So we're just going to put them together. Top is 15. M to the third, m is m to the fourth. The bottom is 8 times 3. But these can be simplified. The 15 and the 24 can be simplified. So I'm going to simplify those. and it becomes 5m to the fourth over 8. So now when I separate these, 5m to the fourth over the square root of 8, rationalize the denominator, multiply by radical 8 over radical 8, multiply the tops, multiply the bottoms. So the top is 40m to the fourth. The bottom, square root of 8 times square root of 8 is square root of 64, which just comes out as a regular 8. But the top does simplify. The top simplifies to 2 times 2 times 2 times 5. 4 times 10 is 2 times 2 times 2 times 5. A pair of 2's comes out. So I end up with 2 radical 10, and the m to the fourth comes out as well. So 2m squared radical 10 over 8. But the 2 and the 8 simplify. 2 goes into the top once, 2 goes into the bottom 4 times. So m squared radical 10 over 4. Try this next one, but make sure that you don't forget about that 4 out front. All right, well, I multiplied the top, 7x to the 9th, multiplied the bottom, 16x to the 7th. The 4 is still out front. Don't forget about that. I almost did in the second step here. But then I saw that I could simplify. Always check if you can simplify here. The x is simplified, so I'm left with an x squared on the top. The numbers don't simplify, but when I split those up, when I separate the top into 7x squared and the bottom into the square root of 16, I notice that the square root of 16 is a perfect square. So the bottom is just going to be 4. The top is still under the square root, 7x squared. But don't forget about this 4 that was out front. So that 4 that was out front cancels with the 4 that was in the denominator, and we're just left with 7x squared. Again, many of these problems can be done different ways, but we'll end up at the final answer. For example, I could have brought this out in the first place and only multiplied by the radical. There's different ways to go about it. Maybe I didn't simplify and I rationalized with the x values. So when you end up at the same answer, you know you did it right. If you did not end up at the same answer, try to go back and do it our way.